Brakes are a critical safety system on any vehicle, and it's very important that you understand how your brakes work.
Regardless of the system, it is imperative to remember that if used incorrectly, brakes can overheat and lose their effectiveness.
This module provides the important information on proper brake application and reviews how to safely operate your vehicle on mountain roads.
In a few minutes, you are going to watch a video.
While watching the video, keep in mind that your vehicle systems and safety features may differ from the Volvo equipment example shown in the video.
Transmission types, axle configurations, and even brake systems vary across Lindy's fleet.
However, the vehicle operation principles remain the same. Reduce load and heat on the braking system through the engine and manage the speed of the vehicle.
Speak with your supervisor if you are unfamiliar with any of the systems used in your fleet.
Take special notes to learn about exhaust brakes, automatic shifters, and control features of your vehicle.
Always follow the instructions and guidance of your supervisor, approved local policies and procedures, and equipment manufacturer recommendations.
Now let's watch the video.
Driving a big truck in the mountains is pretty serious business. One small mistake can make for a really bad day. The problem that most drivers run into is they never get exposure to mountain driving or any experience driving in the mountains until they get there. And we're going to show you how you can take an 8% grade at 102,500 pounds without using any service brake at all. Now that's good driving technique. So you can apply that to a tandem load, a B-train load, a triaxle load, anything you want. Once you know how to do it, and once you understand the risks of not doing it right, you'll be able to keep out of trouble. These videos are made possible by Volvo Trucks North America. Hi, I'm Equipment Editor Jim Park. These videos will demonstrate how to descend long mountain grades like you find in places like British Columbia, Washington State, and Colorado. Lesser grades, as you'd find on Highway 2 in New Brunswick or on Interstate 80 in Pennsylvania, for example, can easily be handled with your engine brake and just a light service brake application. There are 3 other videos in this instructional series. Part 2 features our Chief Instructor Andy Roberts walking us through a brake inspection. Part 3 of this series familiarizes drivers with the signs and warnings they'll see around steep hills and demonstrates how to select and hold a gear using the I-Shift transmission. And in Part 4, we'll hit the road to demonstrate how to descend a long, steep grade. This video is a primer on brakes. We'll cover the basics on brakes, how they work, and what happens to them when they get hot. I should note here that we'll be talking exclusively about S-Cam drum brakes in this video. Disc brakes are a different critter altogether in that heat doesn't affect them in the same way it does drum brakes. Andy Roberts owns a truck training school called Mountain Transport Institute in Castlegar, British Columbia. He's been trucking and teaching trucking in British Columbia's Kootenay Mountains for decades. So let's get started. Here's Andy with a few words on using service brakes on long grades.
So when you think about the service brakes on your tractor trailer unit, they were never designed to hold a vehicle back going down a grade. They're simply there to slow you down for a downshift or to stop you in the event of an emergency or a stop sign at the bottom of the hill. If you rely on your service brakes and heat them up, you're going to get yourself into trouble. If you keep your brakes cold, and you come around the corner and there's a rock slide or a car accident or a slower moving vehicle, then you have lots of braking power to get yourself slowed down to an appropriate speed for that or to even stop. Drivers that are using their brakes and heating them up are taking a risk. And sooner or later, the odds are going to run out and you're going to have an incident.
As Andy says, the key here is to keep your brakes cool for when you really need them. If you descend the hill using either a constant light application, as some drivers have been taught to do, or using the snub method, which consists of a series of firm brake applications, your brakes will get really hot on long grades. Let's take a look at how brakes work and what happens to them when they become overheated. Most people think of brakes as simply 2 surfaces that rub together to create friction in order to slow or stop the rotation of a wheel. That's true enough, but in engineering terms, a brake is a device designed to convert kinetic energy, or the energy from the motion of the truck, into thermal energy, or heat, through friction between the brake linings and the brake drums. The brake drum and the lining material are designed to dissipate heat, but too much heat that cannot dissipate fast enough will eventually overwhelm the brake's design capacity. This renders them progressively less and less effective as they get hotter and hotter. This image here represents the normal operating condition for a brake. The temperature range of a properly functioning brake is about 200 to 400 degrees Fahrenheit, or about 100 to 200 degrees Celsius. At those temperatures, the normal clearance between the brake lining and the brake drum is maintained, and there's no negative impact on the brake performance or stopping distance. Several things can happen to brake drums as they heat up, eventually reducing their stopping ability. That's a condition we often refer to as brake fade. First and foremost, the brake drums begin to expand outward as they get hot. As they expand away from the brake linings, the linings have to travel further to maintain contact with the drum. This results in longer pushrod stroke and reduced braking force applied by the brake linings against the brake drum. The inside diameter of the brake drum can actually increase by as much as 40 thousandths of an inch when it gets really hot. An accepted rule of thumb says that for every 20 thousandths of an inch the drum expands, the pushrod has to travel an additional 1/4 inch to maintain the lining to drum contact. If the brake is not properly adjusted to begin with, things can go downhill pretty quickly. What you see here is a performance chart for a fictitious Type 30 brake chamber, typical of what's found on many drive and trailer axles today. There's a rubber diaphragm inside the brake chamber. On one side of the diaphragm is an airspace that fills with compressed air as the brake pedal is pressed down. On the other side is a pushrod that's attached to the slack adjuster. As the compressed air pushes against the diaphragm, the pushrod is forced out of the chamber. It turns a camshaft which forces the brake linings outward against the brake drum. On the left side of the chart is the output force in pounds that the pushrod exerts against the slack adjuster. Along the bottom is the travel of the pushrod measured in inches. Free stroke, as noted in black on the bottom of the chart, is the distance the pushrod travels from its resting position with no application pressure to the point at which the brake linings contact the drum. The power stroke, which is shown in green, is where the pushrod exerts more and more pressure against the slack adjuster as the brake application pressure increases. This in turn applies more force at the brake linings against the brake drum. At the end of the power stroke, which is about 2 inches for this type of brake, the brake is producing its maximum force. If the brake adjuster is properly adjusted, the pushrod and the adjuster should be at a 90-degree angle. But in the case of a hot brake drum, as when making a steady brake application on a long downgrade, the drum expands and the pushrod travels out further beyond its adjustment limit. You can see on the chart that as the stroke continues from 2 inches out to 2.5 inches and beyond, the force exerted by the pushrod against the slack adjuster diminishes. For example, at 2.5 inches, the force is just 1,500 pounds. That's down from 3,000 pounds at its optimum stroke length. The brake at that point is producing about half of its potential stopping power. To make matters worse, most brake linings lose some frictional capability at higher temperatures, but poor quality linings can lose up to 1/3 of their effectiveness at temperatures above 600 degrees Fahrenheit or about 325 degrees Celsius. This slide illustrates what's happening down at the wheel end. The brake drum is really hot, like over 700 degrees Fahrenheit or 370 degrees Celsius, and it's expanded by 40 thousandths of an inch or so. The pushrod stroke is out to 2.5 inches or more, it's well beyond its adjustment limit, and the slack adjuster is no longer at the optimal 90-degree angle to the pushrod. When the brakes reach this temperature, they'll produce a distinctive odor and usually be accompanied by white or blue smoke. Dangerously overheated brakes can reach temperatures of 1,800 degrees Fahrenheit or about 1,000 degrees Celsius or even higher. These will glow cherry to bright red, and there's a serious risk of a wheel end or a tire fire. That's if the truck manages to stop before it crashes. That covers what you need to know about how your brakes work, the effects of excess heat, and how to inspect your brakes before heading down a long hill. As Andy mentioned right off the top in this video, we want to avoid using the service brakes on a long descent, but it's critical that the brakes be in good condition and properly adjusted before heading down the hill. Coming up next, Andy Roberts will walk us through the walk-around inspection you should be doing in a brake check area before heading down a long grade. In fact, such an inspection ought to be done every time you stop the truck. I'm Equipment Editor Jim Park. We'll catch you in the next one.
You have completed the second module. To move on, complete the second quiz.